Okay, in this video I want to show you how to determine the formula of a compound. Let's have an example. So determine the empirical molecular formulas for a compound that gives the following percentages upon analysis. And the results are based on mass percent. So we have these percentages: 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. And the molar mass of the compound is 98.96 grams per mole. So based on these percentages, we can find the ratio of each element in the chemical formula. For example, we have 71.65 grams chlorine. We know the atomic mass of chlorine is 35.45 grams, so 1 mole of chlorine contains 35.45 grams chlorine. So these two cancel each other, and then figure out 2.021 mole chlorine we have in the formula, in 1 mole of our compound. Next one is the carbon. Again, if we assume that we have 100 grams of carbon, we can say we have 24.27 grams carbon. So the atomic mass of carbon is 12.01 gram carbon. So 1 mole carbon divided by 12.01 gram carbon. So we have 2.021 mole carbon in the chemical formula too. And then finally we have 4.07% hydrogen. So again, if we assume we have 100 grams of our compound, we can say 4.07 grams of it is hydrogen. So atomic mass of hydrogen is 1.008 grams. So 1 mole hydrogen divided by 1.008 grams. It's going to give us 4.04 mole hydrogen. So now if we divide all of them by 2.021, we obtain the empirical formula. The empirical formula is going to be ClCH2. So that's the empirical formula. So now let's see what is the formula weight of this compound and compare it with the molar mass of the original one. So basically what we did so far, if we obtained the empirical formula, we need to compute the mass corresponding to the empirical formula and find the ratio, which is the molar mass divided by empirical formula mass. So we got the molar mass, and here we need to find the formula mass. So for formula mass, we have ClCH2. So basically 35.45 plus 12.01 plus 2 times 1.008. It's going to give us empirical formula mass, so which is 49.48 grams per mole. And the molar mass is given in the question, which is 98.96. If we divide molar mass by empirical formula mass, we get 2. So it means that we have 2 of these empirical formula in the chemical compound. So the molecular formula is going to be ClCH2 and in bracket 2. So we have Cl2C2H4. And the substance is composed of molecules within the formula, and we have Cl2C2H4. Let's have another example. A white powder is analyzed and found to maintain 43.64% phosphorus and 56.36% oxygen by mass. The compound has a molecular mass of 283.88 gram per mole. What are the compound's empirical and molecular formula? So first of all, we need to find empirical formula, and based on that ratio, we can estimate the molecular formula. So we have 43.64% phosphorus and 56.36% oxygen. So again, our basis must be 100 grams of our carbon. So if we put that basis, we can say 46.64 grams phosphorus we have and 56.36 grams oxygen. So that's the atomic mass of phosphorus. 1 mole of phosphorus contains 30.97 grams phosphorus. These two cancel each other, and it's going to be 1.409 mole phosphorus. And here we have 56.36 grams oxygen. 1 mole of oxygen divided by 16.00 grams oxygen. These two cancel each other and we get 3.523 mole oxygen. So if we get the ratio, if we divide it by 1.409, for phosphorus we have 1 phosphorus, and on the other hand we have 2.5 oxygen. And because we need to have whole numbers, so we need to multiply by 2. So we have P2O5, and that's gonna be our empirical formula. So now let's divide molar mass by empirical formula mass. Molar mass is given, which is 283.88 grams per mole, and the formula mass we need to find it based on that. So we have 2 times 30.97 plus 5 times 16. It's going to give us 141.94. So if we calculate the ratio, we get 2. So the molecular formula becomes P2O52 or P4O10. Next example, caffeine contains 49.48% carbon, 5.15% hydrogen, 28.87% nitrogen, and 16.49% oxygen by mass, and has a molar mass of 194.2 grams per mole. Determine the molecular formula of caffeine. So we have 4 different elements: carbon, hydrogen, nitrogen, and oxygen. Again, we need to have a basis, which is 100 grams of caffeine, and see what are the ratios. So we have 49.48 grams carbon divided by 100 grams of caffeine. 1 mole of caffeine contains 194.2 grams, which is the molecular weight of caffeine. So we have 96.09 grams carbon. We can do the same thing for hydrogen, nitrogen, and oxygen. So per 1 mole of caffeine we have 96.09 carbon, 10 grams hydrogen, 56.07 grams nitrogen, 32.02 grams oxygen, and then based on that we can find the number of moles. So we have 96.09 grams carbon per 1 mole of caffeine. That's the atomic mass of carbon, so we can convert this gram of carbon to number of moles. So we can say in each mole of caffeine we have 8.001 mole carbon. We can do the same thing for hydrogen, nitrogen, oxygen. In each mole of caffeine we have 9.92 mole hydrogen. In each mole of caffeine we have 4.002 mole nitrogen and 2.001 mole oxygen. So now we can say the empirical formula, if we consider this one 8, 10, 4, 2. So we can say we have C8, H10, N4O2. So that becomes empirical formula. And we can check the molar mass of this formula. We can say 8 times 12.01 plus 10 times 1.008 plus 4 times 14.01 grams plus 2 times 16. And that's gonna give us 194.2, which is equal to this one. So that's gonna be the molecular formula of caffeine.